morning. Good morning. Now I think everybody is awake after tea and coffee. So from micro, let's go to large scale. So our next talk is about Astronomy Education Research, and it will be given by Professor Eriksson. You can see the name on the slides already. So he has been around as an astronomy and physics teacher for a really long time, and also as an education researcher. He worked at Lund University earlier in Sweden, and presently he is based at Uppsala University. He has promised me he will say more about his own background in his talk, so I'm not going to say a lot. We interacted with him because he's also involved with IU's various efforts with astronomy education research. He was involved with IU Commission C1, which looks after astronomy education in the previous triennium. And also, there is a working group within IU, that is International Astronomy Union, which takes care of astronomy education research activities, and he is chair of that working group as well. So I will hand it over to him to say more about these things.
Thank you. And thank you all for coming and listening today. It's an honor to be here in India. It's my first visit, actually, to India. And to come to Mumbai and to meet you, that is a real privilege for me. So, like I said, I'm from Sweden. How many people here knows where Sweden is? Hands up. Oh, most of you. Very good, very good, very good. So let me see if I can get this running. Yeah, it's quite far away, actually. So I think I will start by showing you a map of where I come from. So this is Europe, and here we have Sweden. And let's zoom in a little bit. So we see southern parts of Sweden here. This is where it becomes more interesting, I would say. And up there in Uppsala, that's where I work. And my home is down here. So I travel on a weekly basis about 600 kilometers to and from work. But that's okay. It works fine. And Uppsala University is the largest and oldest university in Sweden. So I work at the Department of Physics and Astronomy, and I'm running my division there for Physics and Astronomy Education Research. And I will come back more to that later. But before I do that, I wanted to give you a weather forecast for Uppsala. Today, I think, and that was actually yesterday, minus 11 degrees. How does that sound, hey? I kind of like being here, I must say that. And it's going to be cold, but that's typical winter weather in Sweden. So just a few photos of where I live. This is my little house in winter and summer. And yeah, this is work. It's snowing. I got that picture from friends yesterday. So winter in Sweden and also summer in Sweden, which could be quite a different thing. So who am I? With a short presentation from Aniket earlier on, I will build upon a little bit here. I've been in this business for quite some time now. I started off studying mathematics, physics, and astronomy as an undergraduate. And then I became also a teacher, upper secondary school teacher. And I've been teaching a long time, physics and astronomy in particular. I like teaching. I like learning. And I think that is one of the foundations for becoming also an education researcher. You need to be engaged in your teaching, and you need to be engaged with your students, of course. So, during the years at university, I've also been teaching at upper secondary school in different settings. Do you have any international baccalaureate schools here in India? Yes. Yeah. So I taught for 3 years at one of those schools as well. So Also, I've been very much involved in professional development courses for teachers in physics and in astronomy, in particular in astronomy, actually. And I did most of that work when I was director for the National Resource Center for Physics Education at Lund University. The Resource Center is a center where we provide resources then for in-service teachers, mostly. And it was a privilege, actually, to work with that, have that work and work with that group of people in here. So how many in here identify yourself as teachers, say at upper secondary school? Start with that. Okay. So anyone teacher at lower levels as well? Hands up, yeah, some. And the rest of you, of course, then at higher levels, right? Good. So teaching and being engaged in teacher education is something that I really, really appreciate and like. And like I said, that took me into this journey of becoming an education researcher. So physicist by training in my undergraduates, also a teacher by training, but the research I did started in astronomy. In Sweden, we have something we call a licentiate degree. That is half a PhD, more or less. In Sweden, a PhD is 4 years. I don't know if it's 3 or 4 years here. Okay, yeah, 5. So half a PhD, half my PhD was first in astronomy, and I did some work with modeling spotted stars. Fantastically interesting, actually. But I had to quit that because the department where I was doing my PhD crashed, more or less, economically. So yeah. But I was then all the time so fascinated by this fact that the students had such big problems understanding this wonderful universe out there. How come? Why was it so hard for people to understand the universe? I thought it was easy. But obviously the students struggled. And that has kind of taken me into this path of astronomy education research. And I was fortunate to continue my PhD with Professor Cedric Linder at Uppsala University at the time, and ended up eventually finishing that, focusing very much on students' understanding of the 3D structure of the universe, on how we communicate and understand astronomy and the universe. Communication is the key to learning, because if I learn something, how can I tell you that? Well, I need to communicate it somehow. And communication is therefore something that I have studied a lot when it comes to astronomy education research. I'm also a reader. Does that apply to your academic system? Yes, in that. And nowadays, I work then as a full professor at Uppsala University. I have my group there, and about 10 people, some PhD students, some postdocs, and other faculty colleagues. And it feels so good to be in that environment. I don't know how it is here in India, but in Sweden, education research in a discipline is not always seen as a real thing, right, by the other people at the departments. But at Uppsala University, physics education research and astronomy education research is really one of the fundamentals of everything, and it has a very high position at the department. And I feel so happy to be able to work there in that environment. Yeah, I mentioned this before. Let me also say something about another thing that I have started over the years. I together with Paolo Bretons, he passed away, unfortunately, some time ago, but we started the journal, the International Astronomy Education Journal, because there was no place for people to really publish work done in astronomy education, research, and practice. And I tell you, if you have something that you would like to publish in this field, it could be research, it could be related to practice, do consider my journal. because that journal is read by so many people nowadays. So you will have your words spread around the world. It needs to be in English, but that's not a problem here, I understand, right? So we have just announced the 4th volume of this journal now, and we are very proud to be able to say that it's so high quality of the work that we publish, and many people submit to us. It's a pleasure to have all those, and if you are interested in this, please help us a little bit by becoming reviewers. We need reviewers for the journal, because otherwise it takes a long time before papers are being published. So if you feel that you would make a difference, go to the website, click on Becoming a Reviewer, and help me. Thank you. Annika, you mentioned my engagement in IAU, and it's been a long, ongoing story there as well. On top of that, astronomy education researchers and educators, we need to meet every now and then, right? We need to be able to communicate in person like this. Online, well, you know how well that works, right? So it's better to be in the same room as we are today. And Paolo Bertrons and I, we started this astronomy education conferences as well. So we have, until now, had 2 conferences. The first one was in Garching in Germany. The second one, 2023, was in Toronto, Canada. And there is an upcoming one that I would like to highlight here in Melbourne, Australia. And it's by the end of September. So if you have the possibility and would like to engage more in astronomy education on a conference, do consider coming to Australia and Melbourne. So as you see, what I do is to try to build some kind of network around the world where people interested in astronomy education, research and practice can meet, can publish, and communicate. And I think that we are very few, actually, around the globe that has this interest. I am happy to extend it into India now, through Aniket in particular, and in the rest of Asia, because Asia until now has been difficult for me to reach out to, mainly because of language issues, I believe, but I'm still working on it. And here I am today, and that's a good thing. Okay, so that was a short start saying who I am, and I was invited here to talk about astronomy education research, past, present, and future challenges. That is the title of my talk, actually. And I would like here also to acknowledge my colleagues, Saeed Salimpour and Michael Fitzgerald, because the 3 of us, we have worked a lot on trying to get an overview over the field of astronomy education research, historically. And that is what I will talk about today. And we have a paper published in the Astronomy Education Journal on this. So if you are more interested in any details, etc., after my talk, please go there and read it. It's open, it's free. So, some background first. Astronomy education research, what is that? Well, astronomy education research is something that has come from physics education research, actually. It started, physics education research has a longer history than astronomy education research, mainly because there are more physicists involved in physics teaching, I believe. And most of the stuff related to this field comes from America. I'm sorry to say that, in a sense. The world is big, but very much astronomy education research has been done in the US. So it has been dominating the field since the beginning, more or less. And as such, it also had kind of put the limits and things like that to what has been done. And you will see that in the presentation, of course. Also, physics education research is part of STEM education research, or STEAM, as I want to say, because the A, what is that? Anyone knows? Arts, yes, precisely. And where does that fit better than into astronomy, right? With all those beautiful pictures of the universe that you can see. So arts and stuff related to that is what I believe very important in astronomy education research. And all of this is part of discipline-based education research, as we heard from our colleagues here earlier on chemistry. So we have many overlapping ideas, theories, methodologies, etc. But we need to also acknowledge the fact that each discipline is its own. So the hurdles and challenges we have in astronomy compared to, say, chemistry are different. Some of them overlap, yes, but some of them are also very different. So how old is astronomy education research? Okay, when was the first paper published on astronomy education research? Well, we have been working hard to try to find out early papers or publications in this field. And the earliest that we can find, written in English, because that's what one of the limitations are, is from 1898. So that is the starting point in our study for astronomy education research internationally. 1898. That's a long time ago. So what is astronomy education research then? Well, we aim to examine the teaching and learning challenges that when people try to understand the universe. And to do that, we need to use some kind of methodology. And there are, of course, more or less 3 overarching ones that you can talk about, or 2. We have qualitative and quantitative methods. And sometimes we mix them. So 2 or 3 is what we can use. And these are very, very important when you are doing education research. You need to have a thorough, well-known method for finding or trying to dig out the information that you are interested in, that could help you answer the research questions that you have. Also, theoretical frameworks are important. Theoretical frameworks, what is that? Well, I will come back to that later, but it's also one of those things that you need to consider if you want to go into astronomy education research. Maybe you don't have to think too much about it if you are in astronomy education or a practitioner, teacher, etc. But if you want to do research, you need to know your theoretical framework, especially if you want to publish it in my journal. I can tell you that. So what has been done then over time? How has this astronomy education research field developed over time? Let's take a look. I am not the first one, of course, to do this. There's a long list of people who has done efforts in trying to create overviews of astronomy education research previously, of course, and I do encourage everyone who is interested to go into these and read them, because they are very good. However, they are also limited. You see the number of papers here that they have looked at. It's it's a few hundred. But how many papers are there out there written in English since 1898? Well, it's over 2,200. So where are they, and how can we get an overview of all of them? Well, after a lot of work, we created the ISTAR database, the International Studies of Astronomy Education Research database. And this is an open database for everyone to go into and look at. So, and there you have the web page as well. So after extensive searching of all other databases, Scopus, etc., ERIC, whatever we have, we have identified a lot of astronomy education research work. And almost 2,200 papers of astronomy education research and also resources from practice written in English has been identified. And this database is searchable. So to make it searchable, we need to have a number of categories. So when we add a paper or whatever it is to the database, we need to categorize it carefully so it's searchable, of course. And we have made categories for content, for constructs, and much more, of course. So, however, this work will never end, as you understand, because new work is coming all the time, and we identify more work from different countries. Not everything is online. So if you know of a collection of good papers in astronomy education research, or thesis, or masterworks, whatever it is, that could have value for us, please let us know, and we will add it to the database. And again, of course, we need to acknowledge all the work done by colleagues previously, but today iStar is the only maintained astronomy education research database. So some keywords that you can use, you see that in the list over there. There can be more, of course, so we don't miss anything. We are not limited to this, but this is what we came up with after a lot of work on looking into the previous overviews, etc. So when you go to the web page, you come to something that looks like this, and you can search, and you can even just go into different categories. You see how many publications there are of each, and you can go into there and look for what you are interested in. You don't find the papers there, but you find the abstracts and a link to where you can find the paper. You know, we have to stick to the rules, right? So how did we do this? Well, like I said, we searched internet databases using those keywords that are present in this table. And after a lot of work, according to this rather complicated representation, we eventually ended up with a final list that builds the iStar database. And what does it look like then? Well, where do you find astronomy education research in other journals? Well, here's the top 10 list of journals where you can find astronomy education research and resources. Top of the list is the Astronomy Education Review, which is a journal that doesn't exist anymore, but you can still find it on internet and you can search for papers in it. And that's very good, of course. So 22.6%. And then you see the numbers go down quickly. And I'm sure you recognize most of these journals, right? And here, this is actually more or less the background to why we wanted to create the Astronomy Education Journal. Where shall we, as astronomy education people, publish our stuff so that the rest of us can find it? Well, it's a kind of diverse jungle of journals that you can see. And the list, it should go down to at least 100 or something like that. So if you want visibility for your work, well, now you know where to send the stuff, right? Okay. So what are the overarching categories in this database that we use then to try to map the astronomy education research done? Well, we have constructs, we have content, we looked at what different methodology these papers used, which publication type it is, or if it's a resource type, and what target group they aim at. And there are, of course, subcategories within these that I will show you shortly. So, for instance, the detailed content categories are presented here. And it took a long time, actually, to come up with those categories. And it is those here to the right, because there was some previous work done by Salinpour et al. Earlier on, and other people as well, that published something that's called Big Ideas in Astronomy Education. And these big ideas can be read about, I think it's under IAU, right? Yes. So we can find it there. So there are some 11 big ideas identified in astronomy education. And all of these were collapsed into, or extended into, this list of content categories that we have used when we have tagged each and every paper of those 2,200. So what did we find then after a lot of work? I mean, every one of these papers, these 2,200 papers, need to be handled by a person, right? So what we see is that if we look at publications per year since the first paper until 2022, which is where we choose to set the line for this publication, it looks like this. So you see the different colored staples here, and you can see what they are. And well, there wasn't very much happening in the beginning over there. But suddenly something happens, and something more happens, and then again we try to identify different phases historically of astronomy education publications here. So we can see a race around the end of the 60s here, and we believe, without knowing, of course, we can only hypothesize, that this is because of the space race. It started then, flying to the moon, etc. And then, by the end of the 80s, we see a strong increase here in publications. And this is probably mostly due to, at that time in the US, a particular course was created and becoming very popular. It's called Astro 101. And very, very many universities in the US have this course, and there are so many students taking it. So of course also this triggered a possibility to do astronomy education research. But also at this time, we can see the division between physics education research and astronomy education research. So it is actually during this era that astronomy education research becomes its own discipline. And publications increased a lot. We can see that. But until around 2009 or something like that, we have an increase. And after that, there is a plateau for some reason. Why? It's hard to tell, actually. We would probably expect to see an increase, but we don't. And this could be for many, many reasons, of course. Maybe the field becomes saturated to some extent. Maybe it's because of financial reasons, etc. It's really hard to say what's going on. But it's not just a plateau. We can also see that it's going down. And yeah, COVID had a big impact on publication rate. I can tell you that in our field. But also we see that there are spikes that are higher than the other ones here, and these are related to proceedings of conferences. So when there is a conference, say within the IAU or elsewhere, there will be proceedings published, and of course there will be a spike in numbers here. So this is what it looks like historically. And where are the publications from then? Well, if we look at where the countries who represents over 1% then, we see that the US is dominating it very, very much. Over 50% of all publications comes from the United States. And then we have Australia, the UK, and then it goes down quite quickly to Brazil with just over 1%. And I don't see Sweden here, and I don't see India either yet, right? Let us be positive and say, yeah, we're going to do this. We're going to end up on the top 10 list here eventually. So if we try to compare the US with the rest of the world then, how does it look? Well, the blue ones here are the US publications, and the yellow ones are non-US. So what we see is that it's a lot of blue stuff at the very top, not so much yellow. But something has happened here since about 2015 or something like that. And in particular, after 2019, we see that the rest of the world is publishing much more than being done in the US. Again, one can only guess why it is like that. But in 2019, there was a big decline in grants that were accepted for astronomy education research in the US. So interest went down, or maybe not interest, but the possibilities of doing research went down quite much. So the rest of the world had a possibility to increase instead. Here's a heat map of publication type in different eras. So if we look historically, we can see that in the beginning it was a lot of theses that were published only. But that has then declined. On the other hand, we see edited book chapters, very little in the beginning, but a little more over time. Conference items, well, popular nowadays, right? Book chapters or books on astronomy, well, not so many actually has been published. It's kind of low compared to articles, which has been a strong thing from the very beginning and still are, of course. Okay, what resource types do we have then? If we look into those and see how they spread in percentage of the publications here, we can see that some stuff stands out quite much here, the blue and the red. And the blue, that is publications related to curriculum or program description or reports. That is actually not research. That is more reports related to astronomy education. And this is something that dominates the database, actually. Also, we see above 35, 36 something percent is really empirical research on astronomy education. So that's good, of course. And then we see there are position papers or editorial stuff that also is a big part of the database. But the other ones are quite low, actually, here. And theoretical research, in particular, is very low. And that is where I have my heart and interest. So I want to learn about the learning processes, more connected to theoretical thinking, etc. So we need to work on that. What about, again, comparing the US with the rest of the world? Here we can see that if we look at publications connected to school level or to intro level at university, that is more or less what's called Astro 101, we can see that in the US there was a peak around here, 29, and there's a fair normal distribution of that. We can also see that there seems to be a trend of more publications related to school level at the very end now, but the data is low, so well. And if we then compare that result with the rest of the world, we see that the rest of the world is doing astronomy education research in schools, mainly, not at university level. So there's a big difference between US and the rest of the world. What are the target groups then in all those publications? Well, here we can see a diagram showing that. And it's fair distribution more or less here. Some are not so represented, but we can see that lots of it is on college students, and of course middle school students, they also make out a big part of it. The blue one is secondary school students. Again, this is a popular group to do astronomy education research on. And I think it will continue to be that. Primary schools, elementary schools are also quite common, but pre-primary school students, well, very low indeed. There's some work, but not very much work on teachers as well, and how they understand and do teaching on astronomy education. I would see more on that, actually. I'd like that. Okay, so the content is done. Let's take a look at the constructs now. And these are examples of constructs that we have used in the database. And this list is very long, of course. I only show you the first part of it here. But these definitions can be helpful when you want to do, say, a research in the database and see what has been done in what you are interested in. And how are those constructs then distributed, you think, when it comes to percentage of papers here? Well, we see that some are more popular than others. We can see that the most dominant one when it comes to this is content knowledge. There's a lot of research on students' content knowledge. Yeah, and it's mostly from the US, I can say that. We also see that the affective aspect of astronomy seems to be very popular to study. Also, engagement connected to astronomy education seems to be very popular. And, of course, conceptions and conceptual change is also one of those that are very popular to study. And if you want to be, well, affective aspects of astronomy and engagement, that is looking into the most social aspects of what's happening in the astronomy classroom. So not actually looking into astronomy knowledge in that perspective, but it's also so important because we are social beings and we need to understand the social things playing in the classroom, of course, to make it optimal for learning. Well, then you have all the other ones as well represented here, as you can see. Some are very low, like citizen science related to astronomy education. Citizen science and outreach is something that most people at academia is doing, but we rarely write papers about it. We do it because we like it, but we don't publish anything on it, almost. Maybe it's time to do that. Disciplinary literacy, or astronomical literacy, is also a field that we should focus more on, I believe, because I think it's important for the coming generations to be literate in astronomy, like in any other field, of course, to be able to create an awareness about the environment of this planet and the struggle we have of making future bright for our young people. All right, I think it's enough with that for the moment. One can also look at how those constructs vary over time and see if there is any trends or something like that. And if we go into, say, engagement first here, we can see that from the beginning, the first era, it was very little, but nowadays it's more popular to study that. Another thing that stands out is, of course, content knowledge. It's been popular all the time and still are. The affective aspect of astronomy, well, not so much in the beginning, but it's also a very popular field to study. Conceptions and conceptual change, well, fairly popular, and has been popular all the time, more or less, while many others are not so popular. It's actually quite interesting to see that reasoning was popular in this era, but not so popular nowadays, obviously. Yeah. Okay, so if we look at the content distribution, what does it look like then? What is most popular? Well, the gray things here highlighted are the most popular content categories. So celestial motion, which includes seasons, lunar phases, eclipses, that is by far the most popular one, together with instrumentation and techniques, actually. And the reason why this one is so high, almost higher than that one, is the fact that there are nowadays conferences on this around the world. And they publish a lot of proceedings. So it is mostly preceding papers that make out all those publications. We also see then that planetary science, not including exoplanets, but talking about the Earth, the solar system, asteroids, etc., are quite popular. Stars is also one of the fields that stands out a little bit, together with culture and history of astronomy education. The other ones are much lower, as you can see. So now you can think about this. If you want to go into this field and make a contribution, where would you aim? I have that question hanging in the air for a while. What about content over time then? We can see again a development here of some of the different contents. We can see, for instance, that the Earth has been a focus for a long time. It's still popular. Celestial motion again. Okay? Why would that be so popular all the time to study? Well, we come back to that. While other fields are less dominant, we have planetary science is also something. Earth, the planets in the solar system, etc. And instrumentation techniques, not so dominant from the beginning, but suddenly they became a lot more popular to study. One field that is interesting is this, scale and size. Scale and size is a content in astronomy and all other science subjects that we can really think about, because they are kind of the fundamentals or foundations of any understanding of science, right? Big and small numbers, scale, time comes into this as well. This is something that is extremely under-researched, I can tell you that. And if you then compare content versus construct here, you can see that some areas stand out more than others, of course. It's easy to see here that content knowledge related to celestial motion, that is popular to study, of course. But also conceptions and conceptual change in the same field is interesting. How you use representations and visualizations is interesting. And reasoning. Of course, this is one of the most popular areas to study. Earth is also seen here, and etc. You can see that. Interesting is that there is also a content category of no astronomy content. And I tell you that it's quite big. Quite many astronomy education papers don't actually deal with astronomy per se, but with other aspects instead of what's going on in the classroom. Just happen to be in astronomy. And you can do the same thing here. You can look at content versus target groups, where we see primary, elementary school, middle school, etc. Up here, what is popular to study? Well, instrumentation stands out, Earth stands out, and also, of course, celestial motion for almost all age levels here. Stars as well, of course, not so much in primary schools, but still for older kids. Planetary science as well. When we go to teachers, we can look at both in-service and pre-service teacher education and see what's been studied here. And of course, what we can see is what stands out, miscellaneous astronomy content. Well, it's really hard sometimes to categorize what have they studied historically. But, well, it is related to astronomy, at least. Earth is something that is popular when we look at pre-service teachers. Again, celestial motion stands out, etc. Last slide on this. Methodology then, over time. Well, I mentioned that there were 3 different overarching methodology categories: qualitative, quantitative, and mixed methods. And what we can see is that quantitative methods have been popular more or less all the time. Not so much here, actually. But qualitative methods, not so much in the beginning. But it's coming and becoming more and more popular. While mixed methods, where you mix the 2 of them, is something that is being recognized more and more in education research. So you take little of each, more or less, to be able to answer your research questions. So what about theoretical frameworks? Well, actually, we didn't look into theoretical frameworks in all those papers. That is work we have to do for the future. But what one can say is that there are so many theoretical perspectives on learning. So this is just a list that I made up last night when I was thinking about these things. So there are so many, and many, many more, of course. And some of them overlap, some of them are the same thing, just different names, etc. But it would be very good to actually make a classification of all those papers based on theoretical frameworks as well. So, if we then look at what topics in astronomy education research have had significant number of publications, and what topics have relatively small numbers of publications then. Actually, this miscellaneous astronomy content category makes up about 600 of those 2,200 papers, which is very much. And it's a bit sad in a sense because we really don't know what they have studied, astronomy-wise. Well, what is popular then? Well, popular, as we have seen, celestial motion, culture and history, planetary science, stars, and instrumentation. These are the most popular ones. Then we have also cosmology, light, and to some extent, scale and size. Interestingly, cosmology has become much more common nowadays. And we believe that that is because in the curriculum, in the OECD countries at least, cosmology is more dominant nowadays than it was before. So it could be because of that, of course. And the instrumentation category has become popular because of those conferences that have been organized. So what is missing then? That's a good question to ask. We see that content-wise, there is a drop-off at the edge of the solar system. So more or less anything outside of the solar system is not addressed very much historically in astronomy education research, until we come to the very big thing, cosmology. So anything related to galaxies, more or less, empty. And again, we can probably say that this is due to the fact that very little can be found in curricula for school level when it comes to galaxies. They don't, it just isn't there, and therefore there is no research on it. To what extent does the research align with what is generally presented in curricula and for scientific literacy? Well, again, we see this connection to school curricula across the world. It is rather homogeneous, actually. In many countries, it's more or less the same. It doesn't vary very much. And since very much astronomy education research is focused on school level, of course, this will dominate also the categories that we see in the database here. But there are some omissions, like I said. Galaxy astronomy, we don't see very much about that. Astrobiology. Is that interesting for you? Hands up. Yeah, it should be, because that's a fantastic field. It crosses all the science disciplines. I love it. But there is very, very little education research on it. Exoplanets is also one of those things. Every student asks questions about, have we found a second Earth, etc., right? But there is very little research on that too. And then we have this scale and size category also. So maybe we should focus more on this in school as well. If you have the possibility to push a little bit on those who decide what should be taught in astronomy, well, maybe you could do some change here. So, wrapping this up, what recommendations and outlooks are there for astronomy education research then? Well, what we can say here is that children's perception and understanding of seasons, lunar phases, the Earth, Sun, Earth, Moon, celestial motion in general, that has been studied very, very much. I can say that almost half of the publications addresses that. And you should ask then, should this be studied more? I am not standing here saying no, of course. But if you are interested in this and want to do something with your students, say, first of all, go to my database, look what has been done before you decide, right? Maybe you find a white spot there, go for it. But otherwise, check if other people haven't already done what you are asking. It's a big risk. And it would be very bad if you do that, because then maybe your manuscript will be rejected because the reviewer says this has already been done. Outside the solar system, well, content related to that seems to be less research. Scale and size, again, it's very fundamental and a threshold concept for understanding the universe, from the smallest to the biggest. Time. My time is almost out. Annik is waving his hands now. But that is also very little researched. Astronomical literacy, again, it should be important, but research on it seems not to be. And there's a connection that I said before to outreach, of course. Should it be part of the astronomy education research? I don't know. International collaborations. Only 4% of all publications are international, that is, have collaborators from different countries. 4%. So maybe you should collaborate with people around the world. The curricula at school level seems to be close enough in many, many countries for collaborations to be possible. And you can, of course, check that in a research project. So, conclusions. Astronomy education research is a growing discipline-based education research field, over 100 years old. US has dominated it, like I said. There are some content that is really well researched, celestial motion, like I said, Earth, instrumentation, etc. And other fields that are not so well researched. Astronomy, historically, has focused very heavily on content knowledge, on effective aspects, and also engagement. Consider that when you choose to look into this field eventually. In terms of methodology, then, we can see that there is a spread about those different types of papers. More general reporting stands for 43%. Well, how interesting is that in a research perspective? That's up to you to decide. But there are also full empirical research papers, 36% approximately. But others are not so well represented. And this, my friends, concludes this outlook that I wanted to give you. I hope you find it interesting. I think that it's a challenge when going into this field. I know that there are sitting now in this room both researchers and teachers. And I encourage every one of you interested in astronomy to make a project, do something, look at the database, see what others have done, and come to me with questions if you have them. I can try to guide you if you have ideas. I can say, this is a great idea. And if it's not a great idea, I say, this is a great idea, but, yeah. Thank you so much for listening.
Thank you, Professor Eriksson. Any questions from audience? Yes, maybe.
Speak loud, because I have a small hearing disorder, so.
No, you might have already mentioned it, but maybe I missed it. I mean, this construct, you gave a number of constructs. Does it make sense to use astronomy and, teaching of astronomy and nature of science? Is that included in your?
It is in a sense.
How astronomy teaching helps improve, understanding of nature of science, because nature of science is a general topic of great importance.
Yeah, if I understand you correctly, I mean, when we look at what has been studied and the categories that we have used, all of those papers, of course, are related to the education part, and there is a result and some kind of conclusions in those. These have not been categorized by us. So one have to read those papers to see what are the implications for teaching and learning in those papers, based on the categories that we have used in this database. So my answer is probably no, but it's possible to find the answer by going for those papers.
Okay, thanks.
Take one question from the back, or say Bas.
Go ahead.
Thank you. One of the points that you mentioned in your talk is about visuospatial imagination or reasoning as an important part of AER. I think one hurdle that one very frequently comes across in school-level teaching is the inability of students to imagine the tilt of the Earth and the ellipticity of the orbit and so on, which has various implications to life on Earth. Are you aware of any quote-unquote reasonable models that students find easy to engage with, which obviate the problems that naturally arise because of the scale and the three-dimensional nature of the problem and so on?
Absolutely. Actually, since there are a lot of research on this in the database, many papers focus on the possibility of doing different types of teaching exercises and things like that, using mainly three-dimensional models in the classroom. So that is definitely a way forward, and the research shows results that this is good for students' understanding of these things that you mentioned. So that is definitely a recommendation to do that. It's cheap, it's simple, it engages everyone, it engages your body, because the embodied part of learning is so important. And many people don't think that that is possible in astronomy, but it is. To have people walk around each other, creating a planetary system, say, or creating the phases of the moon, etc. That is a strong experience that makes a big difference. So that is the first part of the answer. The second part is to use visualizations, computer simulations, if possible, to show those things. And there are lots of them out there. Some of them are better, most of them are worse. But again, in the database, there are good examples of those things. So, yeah.
Do you have a ranking of those?
I'll tell you later.
Pass the mic.
this is perhaps a question for somewhat senior students, undergraduate, or perhaps even graduate students who want to go into astronomy as research.
Yes.
Now, in order to do astronomy, you have to look at the universe. And the facilities for such looking are in building telescopes, having large-scale computers. And there is a long process of developing these telescopes and these computational resources. So, and there is considerable amount of politics and considerable amount of social and economic dynamics that goes around these
Absolutely,
aspects.
yeah. And it takes a long time.
And this is also both national as well as international. Nationally, we have been affected by the lack of telescopes when I came into astronomy in India. But the thing changed quite rapidly with the development and construction of the radio telescopes.
Yes.
And internationally also with the development of Hubble Space Telescope and Chandra and all that, you speak about this 101 bump in the late 80s.
Yeah.
But one of the key reasons why astronomy became so popular at the later levels is the availability of such facilities.
Like the Hubble Space Telescope.
Space-based telescopes and larger ground-based telescopes. So is the field of looking at the politics and the economics and the dynamics of development of these instruments and these facilities of interest to astronomy educators?
I think it should definitely be, because it's such an important...
What about your own journal,
Yeah,
iStar?
precisely. We don't have any publications in my journal for the moment on this. I would love to see it, because I think it's important. It's part of this miscellaneous astronomy content in the database. But there is way too little. I mean, very few people ask questions like the one you just posed here. I must say that. And I'm sorry for that, because it creates the possibility and grounding for creating an interest and having more students coming into the field. We need that. We need good, sharp students to come into the field of astronomy and astronomy education for the future. And nowadays, I think it's kind of sad, because access to the sky today is so limited for most people on this planet. I mean, last night we saw a very nice display of the moon and Venus when we had dinner. That was fantastic. And some colleagues here said it's kind of unusual because of light pollution and pollution in general. And if you live in a city, where most people do today, it's really hard to see anything. I did a large international outreach project on star spotting to map light pollution in different areas, or to create awareness about light pollution. And it was sad to see the results, actually, because in most countries, people don't see stars. Maybe you see a handful of stars only in the sky, unless you live on the countryside or on an island, etc. So access to the sky is limited. And when you go into education on this and want to become a student, master student or wherever, what you can do then is to have access to large facilities. But usually that happens through online services. So you can use computer, you can connect through your computer to those facilities. But actually going there, being there, experiencing the night sky is something that I encouraged everyone to do. Go out, look up. What do you see?
Thanks. I have been reminded that we are running over time, so I will not take additional questions at this stage. But he is there throughout the conference all 4 days, so you can catch him in any of the breaks and talk to him. Thanks.
Thank you again.